Welcome to Dark Sky Dive. When we think of vast oceans, we naturally picture Earth, the blue marble floating in space. We visualize rolling waves crashing on sandy shores, a thin layer of vibrant life clinging to the surface of a rock. For centuries, humanity believed that oceans were rare, a fragile accident that was unique to our own warm and rocky world. But far beyond Earth, and far beyond the warmth of the sun, there exists a place where oceans defy our expectations. In these distant reaches, oceans do not sit on the surface. They are hidden, buried beneath miles of thick, solid ice. Locked inside frozen moons orbiting a distant gas giant, these waters remain unseen, waiting for us to discover their deep secrets. This is the incredible story of Saturn and the largest, most mysterious oceans that human beings have ever discovered in space. A ringed giant hiding a secret that challenges our understanding of where life could potentially exist in the vast universe. Saturn is famous for its rings. They are elegant, delicate, and seemingly peaceful structures that have captivated astronomers for centuries. But Saturn's true secret doesn't lie in the rings we can see. It lies beneath the icy shells of its moons. More than 140 confirmed moons orbit Saturn, forming a complex system of worlds shaped by gravity and time. Among this crowded family, two stand out above the rest: Enceladus and Titan. Together, they hold something truly extraordinary within. They contain an amount of liquid water that may exceed all of Earth's oceans combined, hidden beneath their frozen exteriors. At first glance, Enceladus looks unremarkable. It is small, only about 500 kilometers wide, bright white, and frozen solid. But in 2005, NASA's Cassini spacecraft witnessed something no one expected, changing our view of this moon forever. Enceladus was erupting. Giant plumes of water vapor and ice particles were blasting out from deep cracks near its south pole. These jets were shooting hundreds of kilometers into space. This wasn't just surface ice melting under the weak, distant sunlight. This was an ocean below. Further investigation revealed the truth beneath Enceladus's icy crust, estimated to be 30 kilometers thick. There lies a global ocean of liquid water. Not frozen, not trapped in pockets, but warm, flowing, and surprisingly dynamic. This ocean is kept liquid by tidal heating. As Enceladus orbits Saturn, immense gravitational forces stretch and squeeze the moon. This generates heat deep inside, much like bending a paperclip until it grows hot, preventing the ocean from freezing solid. Astonishingly, that ocean is in direct contact with a rocky sea floor, following complex chemical interactions to occur in the dark. When Cassini flew through Enceladus's plumes, it didn't just detect water. It found salt, organic molecules, and vital hydrogen gas. Hydrogen gas is especially important. On Earth, hydrogen released from seafloor vents feeds entire ecosystems that exist without any sunlight. This means Enceladus has liquid water, energy, and chemistry. These are the three key ingredients for life as we understand it. All of this exists inside a moon smaller than the state of Arizona, challenging our definition of a habitable world. Now let's move to Titan, Saturn's largest moon. Titan is bigger than the planet Mercury and wrapped in orange haze. For decades, scientists couldn't see what lay beneath. Its thick atmosphere hides the surface completely from our optical telescopes. Then Cassini arrived, dropping the Huygens probe, and what it found beneath the clouds changed everything we knew about Titan. Titan has rivers, it has lakes, it has seas, but they are not made of water like the ones on Earth. They are made of liquid methane and ethane, flowing across the surface under an alien sky, creating a familiar yet toxic landscape. Yet beneath Titan's icy crust, possibly 100 kilometers thick, lies something even more astonishing than the surface lakes: a massive subsurface ocean of liquid water. This ocean may be 10 times larger than all of Earth's oceans combined. Let that sink in. A moon where water is hidden so deep and so vast, it dwarfs everything on our planet. Why haven't we seen these oceans before? Because for most of human history, we were looking in the wrong place. We assumed oceans needed warm temperatures, sunlight, and surface conditions like Earth. Saturn's moons shattered that idea completely. They showed us that oceans can exist in total darkness, heated by gravity alone. They don't need stars to survive. They don't need thick atmospheres like ours. They just need energy, chemistry, and time to develop stable liquid environments. When scientists add it all up, the oceans of Enceladus, Titan, and other icy moons in the Saturn system are staggering. There may be more liquid water orbiting Saturn than exists on the entire surface of Earth. The numbers are incredible. Earth, once thought to be the unique ocean planet, may not even come close to the water volume of the outer system. Could life exist there? This is the question that changes everything about our place in the universe and our future exploration. If life can exist in Enceladus's dark ocean or Titan's hidden seas, then life may be common in the universe. Not just on warm, Earth-like planets, but beneath ice, in darkness, far from stars. The possibilities are endless. NASA is already planning future missions, probes designed to sample plumes and landers that could one day drill through ice. Even submarines sent to explore alien oceans. For the first time, humanity is not just searching for life on planets, but inside moons. Saturn's silent revelation is profound. Saturn doesn't look dangerous or violent, yet it hosts important discoveries. Worlds with oceans bigger than Earth. Worlds that challenge our definition of habitability. Worlds that may already be alive today. The universe didn't hide its water. It hid it beneath ice, waiting for us to learn how to look deeper. And as we continue to explore Saturn's moons, one truth becomes clear. Earth is not special because it has oceans. Earth is special because its oceans are easy to see. But the true oceans of the universe are hidden in the dark. Let us return to the rings for a moment. They are not just debris. They are remnants of a violent past. Some theories suggest the rings were formed by the destruction of an ancient moon, one that perhaps also carried water. If that is true, then the water in Saturn's system has been recycled over billions of years, moving from moons to rings. The tiger stripes of Enceladus are the scars of this activity. They are the open wounds where the ocean bleeds into space. Infrared scans show these cracks are warm. This heat is the smoking gun of the tidal energy churning deep within. It proves that the ocean is not stagnant. It is a circulating system, transporting nutrients from the core to the surface. If microbes exist there, they could be swept up in these currents and ejected into space, waiting for us to catch them. We don't need to drill through kilometers of ice to find life. Enceladus is offering us free samples of its ocean. On Titan, the cycle is different. Methane rains from the sky, carving channels and filling lakes, mimicking Earth's water cycle. But Titan has two oceans, the surface methane ocean and the deep water ocean. Two completely different worlds in one moon. Could these two worlds interact? Could organic materials from the surface seep down into the water ocean beneath the ice shell? If they do, Titan's deep ocean could be a chemical soup rich in the building blocks required for complex life forms. NASA's Dragonfly mission will soon fly in Titan skies. It will hop from location to location, analyzing the chemistry of the surface. It seeks to answer how far chemistry can go toward life in an environment that is totally unlike our own Earth. Saturn is like a mini solar system. It teaches us that variety is the rule, not the exception, in the cosmos. Even moons that look dead, like Mimas, are now being investigated for possible hidden oceans. The hunt is expanding everywhere. Recent studies of Mimas's wobble suggest it too might harbor a young, stealth ocean beneath its heavily cratered surface. If Mimas has water, then ocean worlds are likely standard equipment for gas giants across the entire Milky Way galaxy. Imagine the billions of gas giants in our galaxy. Each one could host a family of frozen, ocean-bearing moons. The number of habitable worlds might be thousands of times higher than we estimated when we only looked for Earth-like planets. Enceladus remains the most promising. Its ocean is accessible, its chemistry is right, and it has been active for eons. Stability is key. Life needs time to evolve. The tidal heating of Enceladus has likely kept its ocean liquid for billions of years. On Earth, life started quickly in the oceans. If the same happened on Enceladus, it has had plenty of time to diversify. Creatures there would not need eyes. They would sense heat, vibration, and chemical gradients to navigate their pitch-black world. We protect these worlds. Cassini was crashed into Saturn to ensure it never accidentally contaminated Enceladus with Earth bacteria. Planetary protection is taken seriously. We must ensure that if we find life, it is truly alien, not something we brought. New tools are joining the search. The James Webb Space Telescope is analyzing the light from these moons for biosignatures. It can detect the chemical composition of the plumes from millions of kilometers away, adding to the data Cassini left behind. Missions to Jupiter's moon Europa will refine the technology we need to eventually return to the Saturnian system with better tools. Scientists are proposing an Orbolander, a spacecraft that orbits to collect plume samples and then lands to study the ice. It would search for amino acids, lipids, and the structural patterns that only life can create, answering the ultimate question. Finding life on Enceladus would prove that biology is a universal process, not a miracle unique to the planet Earth. It would mean a second genesis. Two independent origins of life in one solar system would imply a universe teeming with life. The next generation of scientists will be the ones to interpret this data. The journey to Saturn is a long-term commitment. Saturn has always inspired us, but reality is proving to be far stranger and more wonderful than any science fiction story. Imagine standing on Titan. The gravity is low. You could strap wings to your arms and fly through the thick air. It is a world that invites exploration. A world where the environment is harsh yet strangely accommodating to human ingenuity. Future bases might float on these methane seas, using the hydrocarbons as fuel to power their research and survival systems. The view of Saturn from Titan would be spectacular. A massive, glowing arc dominating the sky, illuminating the night. Eclipses there would last for hours, plunging the moon into deep darkness, lit only by the reflection of the rings. On Enceladus, the ground itself moves. The ice shell rotates at a different speed than the core, creating constant stress. Saturn sings too. Cassini recorded the eerie radio emissions from the planet, a song created by its intense magnetic field. Enceladus feeds this field. The particles it ejects become plasma, trapped in Saturn's magnetic web, connecting moon to planet. The E-ring of Saturn is made almost entirely of ice from Enceladus. The moon is literally painting a ring around its planet. It is a cosmic connection. Material from the deep ocean of a moon ends up raining down onto the gas giant. This creates a dynamic ecosystem of matter. Nothing is static. The Saturnian system is a living, breathing machine of gravity. Jupiter has Europa, Saturn has Enceladus. These twin pillars of hope are our best bets for finding life beyond Earth. While Europa is larger, Enceladus is more active. It shouts its secrets to space, while Europa whispers them through thick ice. This makes Enceladus the easier target for the near future. We can taste its ocean without ever touching its surface. Prioritizing these missions is a choice. It is a choice to value knowledge and the search for our cosmic origins. These worlds are pristine. They are untouched, natural laboratories that hold the records of the solar system's history perfectly preserved. Studying them helps us understand Earth. By seeing how oceans behave elsewhere, we learn more about our own planet's climate. Titan's atmosphere is the closest analog to early Earth. It is like looking back in time at our own planet. Before life oxygenated our atmosphere, Earth might have looked much like Titan. Studying Titan is studying our own deep past. The complex organics called tholins that rain down on Titan could be the same stuff that jump-started life on Earth. In labs on Earth, we simulate Titan's air. We create these building blocks, proving that the chemistry of life is natural. It is a universal recipe. Carbon, hydrogen, nitrogen, and energy. The universe cooks with the same ingredients everywhere we look. If our solar system has 2 or 3 ocean worlds, imagine the billions of others waiting in the dark across the galaxy. We are finding exoplanets that are water worlds. Entire planets made of deep oceans with no land in sight. Enceladus teaches us that water doesn't need to be on the surface to support life. It expands the habitable zone. The Goldilocks zone is not just a distance from a star, it is anywhere energy and water can coexist together. Saturn is an oasis. In the freezing void, it holds warm hearts. It is a testament to nature's resilience and creativity. Every crystal of ice on Enceladus tells a story of the water below. It is a frozen messenger from the deep. Water is the medium of life, and Saturn has stockpiled it in vast quantities, keeping it safe under a protective shield. When you look at Saturn in the night sky, don't just see a ringed planet. See it as a chaotic reservoir. See it as a collection of worlds. A place where huge waves might be crashing in the dark right now. Where vents are spewing heat. Where strange chemistry is brewing in the crushing depths, hidden from our prying eyes. From Saturn, Earth is just a pale blue dot. But we are looking back, reaching out to find our reflection. Our robots are our eyes. They go where we cannot yet go. They touch the water that we cannot reach. The story of Saturn's oceans is just beginning. We have scratched the surface, literally and figuratively. The best is yet to come. As technology advances, we will return. We will drill. We will swim. We will finally answer the question, are we alone? Earth is not special because it has oceans. That was a misconception born of our isolation and lack of vision. Earth is special simply because its oceans are easy to see. The universe is wetter and more alive than we dreamed. One day, a human might stand on that ice, look up at Saturn, and know that life is everywhere. Until then, we keep watching, we keep listening, and we keep dreaming of the dark oceans waiting in the sky. Thank you for joining us on this deep dive into the hidden waters of our solar system. It has been a journey. If you enjoyed this exploration, please like and subscribe. Your support helps us uncover more secrets of the vast universe. This is Dark Sky Dive. Keep looking up and never stop wondering what lies beneath the surface. See you next time.